Deep in the heart of our galaxy, something impossible exists. A region of space where time crawls to a halt, where light itself cannot escape, and where the very fabric of reality gets twisted into shapes that would make your mind reel. We call these monsters black holes. Tonight we're going to dissect the anatomy of these space-time predators. We'll witness the violent birth of stellar corpses so dense that a teaspoon would weigh as much as Mount Everest. Picture the ultimate cosmic deadline. A star 25 times more massive than our sun has been burning for millions of years, fusing hydrogen into helium, helium into carbon. But deep in its core, something terrifying is happening. When a massive star begins fusing iron in its core, it signs its own death warrant. For its entire life, this stellar giant has been locked in an epic battle. Gravity trying to crush the star into oblivion, but nuclear fusion pushing back with the fury of billions of hydrogen bombs. Iron fusion doesn't release energy, it absorbs it. Suddenly, the star's nuclear furnace goes cold. The outward pressure vanishes in an instant. What happens next occurs so fast your brain can barely process it. In less than 1 second, the star's core, larger than Earth, collapses down to a sphere just 12 miles across. We're talking about matter being crushed beyond anything in the normal universe. Protons and electrons get mashed together so violently they form neutrons. Atoms simply cease to exist. The material becomes so dense that a single drop would weigh more than all the skyscrapers in Manhattan combined. But for the most massive stars, even this isn't the end. The collapse doesn't stop. It keeps going past any size we can meaningfully measure. This singularity warps the fabric of space-time around it so severely that it creates a boundary beyond which nothing can escape. This boundary is the event horizon. The event horizon isn't a physical surface you could touch. It's more like a point of no return written into the geometry of space-time itself. A black hole with the mass of our sun would have an event horizon about 3 miles across, but supermassive black holes can have event horizons larger than our entire solar system. Now let's talk about what black holes do to time itself. Imagine you're watching a friend fall toward a black hole while you remain safely far away. As your friend approaches the event horizon, something strange happens. From your perspective, they begin to slow down. Their movements become sluggish. To you, your friend appears to freeze just at the boundary of the black hole, gradually fading from view as their light is stretched to wavelengths you can no longer detect. But from your friend's perspective, they don't notice time slowing down at all. They cross the event horizon in a perfectly reasonable amount of time. Once past the point of no return, the falling observer experiences tidal forces, gravitational gradients so steep they can tear apart anything that encounters them. Your feet experience stronger gravity than your head. Scientists have a technical term for this process: spaghettification. As you fall inward, the intense gravitational field would act like a lens, bending light from all around the universe. You might see the entire cosmic history flash before your eyes. Black holes aren't just cosmic vacuum cleaners. When matter falls in, some gets accelerated to near light speed and shot back out in jets that extend across thousands of light years. These jets act like cosmic thermostats, regulating star formation across entire galaxies and shaping the evolution of the universe itself. Black holes can act as gravitational lenses, bending light from distant objects and allowing us to see farther into the universe than should be possible. In 2019, scientists achieved the impossible. They photographed the shadow of a black hole, revealing the ring of fire surrounding the event horizon of M87's supermassive black hole. When black holes collide, they create ripples in space-time itself, gravitational waves that carry the news of these cosmic catastrophes across the universe. Every major galaxy has a supermassive black hole at its center. These aren't cosmic accidents. They're fundamental components of cosmic architecture. Black holes have revealed that reality might be far stranger than we imagine, suggesting our three-dimensional universe might be encoded on a two-dimensional surface, like a cosmic hologram. The anatomy of a black hole reveals the universe at its most fundamental level, forcing us to confront the deepest questions about space, time, matter, and the nature of reality itself. These cosmic monsters aren't just destroyers. They're the universe's way of exploring its own limits and showing us that reality is far stranger and more wonderful than we ever imagined.